Hello everybody! In this new tutorial we are going to explain how to configure a ctrlXDrive to work in ProfiNet. In this document we will see the generic configuration and some difference with respect to the previous use of the Indraworks in ProfiNet. In the manual we will also see the operation of the FB that I have prepared for the activation and status of the ctrlXDrive. So, in the first step, we must select the protocol ProfiNet. This is in the usual part, as it will be in an Indraworks. However, we can observe two things. First, must select the Circus profile option as application profile, since now the system uses the profile for communication with the master. The other part is that the device name must match, as was done before, with the one assigned in the master part. Okay, then we will proceed to program the part of slot 0, consumer. Unlike previous generation of Indraworks, in this case, as you can see, we not have the bus control word P4077, but the system, begin profile circles, selects the control word is 134. In the structure, as you can see, the parameter is 00346 has been added to be able to control the axis in jogging mode and in position mode. The rest of the parameters are thus usually used for axis control in position mode, including parameter is 445 as a rule, which it is configurable, which allows us to activate, among other options, the referencing modem for incremental encoders and that of the absolute encoder, and also the ctrlXDrive fault reset. It is extremely important to take into account the value that appears in the current connection length, since due to system misuse, it is not adjusted to the reality of the parameter assigned in the table. In the part of slot 1 producer, up to 4 empty words have been incorporated at the end of the structure to leave the size of both slots the same size. Also, as in slot 0, the number of bytes maintains a certain discrepancy of the theoretical reality. If on any occasion it is not possible to incorporate the communication parameter from the slot 0 and slot 1 tables, they can be accessed directly from parameter is 1050.0.6 and is 1050.1.6. As we have previously indicated, the structure of total bytes is altered by the offset systems. If we look at the occupation structure based on the parameter placed in the slot 0 table, we will see that there are 24 bytes in total. However, if we see this in reality and assign these areas to a device that begins with the IO address at 10, we will see that 2 bytes are incorporated into the communication frame, and therefore we get the 26 that we are in the current connection length. This is because the system used the 4-byte D-word format. In slot 1 producer, exactly the same thing happens. Only in this case, and continuing with the start example in IO area 10, the only point affected by the structure is the assignment of the last 2 bytes that end configuring the 26 of the current connection length. Any modification that we make in the communication frame must be validated using the following activation order. First pre-OP and then OP. The configuration of the signal control and the status word is only provisional and oriented to the example. In this case, for the control word, we have the reference parameter of the encoder in incremental mode, the absolute encoder, and of course the fault reset. In the signal status word, at the moment we have the reference axis indicator and the one that tells us as the axis is in standstill. The word mode to select is drive ctrlX positioning, with which we can access the parameter that we have introduced in the communication frame. In this sheet, we can see some of the parameters used in the frame, the general control and status words, and the positioning word that we will use it to activate the moving in jogging mode and in positioning mode. We now go to the configuration of the axis in Indraworks. First of all, we must install the ctrlXML files of the ctrlXDrive in ProfiNet, and for this we will look for them in the path where we have them saved. Then we will proceed to perform a scan using the scan for devices function. If we have performed the frame activation operation described on page 10, the ctrlXDrive and the previously configured frame should appear. If this does not happen, we will have to return to the communication protocol and activate pre-OP again and then OP. As if on another ProfiNet element, we will introduce a name which shall correspond to the one placed in the ctrlXDrive during each configuration, and introduce an IP and subnet mask. Then we must press the set name and IP option to validate the values entered, and to finish, we add the access to the project using copy all devices to the project, and next close. Once the axis is inserted in the project, it should appear as follows. Contrary to the previous versions of Indraworks, in ctrlXDrive, the data received and sent are grouped as can be seen in the image in separate parameters, so to know what IO occupies each structure, you must enter it individually. The data sent to the ctrlXDrive is as follows, and as you can see, each parameter and its IO area, including the dummy parameter. It is recommended that you activated one of the variables update options located at the bottom and on the right. This allows an automatic refresh of the IO. The case of the data received from ctrlXDrive is exactly the same as that described above for those sent. The communication configuration will be carried out as follows, although this will also depend on the condition of the ProfiNet lines of each machine of each installation. The master part has two different configuration parts, the definition of the master area and, on the other hand, the slave area. Obviously, these areas are modifiable and we can choose the ones we need. The slave must be configured with the same name that we have placed during each configuration, and the IP must be assigned within the range established in the master for the slave. Next, we are going to see the operation of the function block that has been created to control the activation and state of the ctrlXDrive. In this first part, we see the setpoint data, position, speed, acceleration, deceleration, as well as the conversion factors, so that the data sent is correctly interpreted by the ctrlDrive parameters. The next part shows us the activation control. This data related to parameter is 434, control word, and is 346, positioning control word. So that from these bits we can put the axis in halt mode, in AF mode, select the plus and minus jogging modes, select the type of movement in positioned, absolute or relative, the toggle bit for the acceptance of the new destination point. The signal control word is placed for access to the configurable bits, which in this case will allow the referencing of an incremental encoder, an absolute encoder, and error reset. Another important point is the definition of the EO areas and their assignment in the IFB. The way the function block is built, and it is only necessary to place the initial value of the EO areas, so that internally the IFB already extracts the rest of the parameters. This facilitates the programming since only the first of the areas must be taken into account. Regarding the outputs of the function block, this has the indication of reference axis, axis in standstill, axis in position. If the axis is in fault, the status of the axis and the current position, and also current speed. And the diagnostic status sent by parameter is 319, with which we can always see the internal message the axis is sending. In this part, we have the signal status word, which, as we said before, tells us that the axis is referenced and in standstill, but builds also appears as we have seen in the outputs of the module itself. In the video, you can check the operation of the IFB. Activation of the halt mode, axis with torque. In all cases, the axis status is displayed at the diagnostic output using the parameter is 319. Activation of IF mode, axis with an active work mode, drive controlled positioning. Activation of boot direction in jogging according to the set speed. Activation of the absolute positioning mode, for which the axis must be previously referenced. When the destination position is reached, the done bit is activated, which is controlled according to the offset post OK parameter, and is used as an OK position window on the current position and the command position. The start post bit always works on the positive edge and is managed internally. This is done in this way to avoid files pulse problems, basically in the additive and relative operation modes. The speed change works automatically after a value change, as can be seen in the speed feedback. Next, we will see how the ctrlXDrive from TIA portal. The communication structure is similar to the one used in the example with XM. However, in this case, the torque feedback value has been added as the received value, although the general structures are maintained with 26 bytes both on the input and output levels. Obviously, the next step is adding the file XML in the system. Once the modules are inserted, we can see the different configuration options. The heat modules correspond to the type of ctrlXDrive available. The modules are the main structure that allow us to use the certain predetermined communication structures that, however, as we will see on the next page, appear individually. The submodules allows us to insert parameters not contemplated in the module's options and allows us to modify the communication structures in the way with them most convenient. The insertion of the input-outputs modules generates a minimum standard configuration for communication that we can place by dragging and dropping on the correct part. To add user parameter or simply modify the communication structure, we must use the submodules. These submodules have the input area and the output area, so this must be taken into account when inserting a new parameter in the communication frame. In the device overview part, the following configuration has been made for communication, inserting the input and output submodules and respecting the communication structure used in the previous example made with XM. Remember that in this case the torque feedback value has been added to the communication frame. Contrary to what happened with the XM in TIA portal, no type of offset is generated, so the structure itself has seen the correct relationship in the IO used. Master IP assignment in TIA portal. Assignment of the IP for the ctrlXDrive. This IP is assigned automatically from the PLC. This is the IFB used to control the movement of the control drive. It is similar to one as described in the section dedicated to the XM module. And like this, only the initial area of the EOS is used to control the data received and sent. The FB module is in a library made in version 15 of TIA Portal, and in this sheet we can see the process to insert into the project. The FB has the same entries described in the FB of the exam, although in this case the torque feedback value has been incorporated into the outputs. I hope you have found it interesting, and any question you may have, don't hesitate to contact me. Thank you very much.